Distributive law uses multiplication together with addition. Here we have a product. The factors are x and x plus 9. Using the distributive law of multiplication over addition, where each term is multiplied by x, resulting in x times x plus x times 9, and simplifying x squared plus 9x. If we use the distributive law in reverse, we have the basis of a process called factoring. You can think of factoring as code word for dividing, which is the opposite of multiplying. Using the distributive law to factor x squared plus 9x, you factor each term and see a common factor of x. Using the distributive law results in the factored form for this polynomial, which is the product of the common factor x and the binomial with the common factor divided out, which is x plus 9. Another example for using the distributive law in both directions starts with this product. The factors are 8x and the trinomial shown. Using the distributive law of multiplication over addition, where each term is multiplied by 8x, results in the following, and simplifying 24x to the third power minus 32x squared minus 72x. Using the distributive law in reverse, we can factor this polynomial. You can think of factoring as code word for dividing. Using the distributive law to factor the trinomial, you factor each term and find a common factor of 8x. Using the distributive law results in the factored form for this polynomial, which is the product of the common factor and the trinomial with the common factor divided out. Multiplying this back together should equal an equivalent expression that we started out with. Notice that each of these factors has nothing in common with each other than 1. Factoring to form an equivalent expression for 6x minus 2, 4 will require us to write the factorization of both terms. Since both factorizations include the factor of 6, this is the largest common factor. Using the distributive law, we can factor the binomial into an equivalent expression of the product of the largest common factor and the remaining binomial after 6 has been factored or divided from each of the terms. To check the factored answer, we simply multiply to determine if we have an equivalent expression. 6 times x, 6x, 6 times negative 4 is negative 24. Factor to form an equivalent expression for 8x squared minus 32x, a common factor may contain a variable. Both factorizations include the factor 8. The largest common factor of the variables is x, which is the smallest power of x in the original polynomial. Thus, the largest common factor is the product of the largest common factor of the coefficients, which is 8, times the largest common factor, the variable in all the terms, which is x. Factoring each term with regards to the largest common factor results in 8x times x for the first term and negative 8x times 4 for the second term. Then, using the distributive law, we can factor this binomial into an equivalent expression of the product of the largest common factor 8x times the remainder when 8x has been factored out, which is x minus 4. Again, to check the factored answer, we simply multiply to determine if we have an equivalent expression. Factor to form an equivalent expression for 18x to the power of 5 plus 27x squared. First step, determine the largest common factor. Both factorizations include the factor of 9 on the coefficients. The largest common factor of the variables is x squared, which is the smallest power of x in the original polynomial. Thus, the largest common factor is the product of the largest common factor of the coefficients times the largest common factor, the variable in all of the terms. Factoring each term with regards to the largest common factor results in 9x squared times x to the third plus 9x squared times 3. Using the distributive law, we can factor the binomial into an equivalent expression of the product of the largest common factor, shown here, 9x squared, times the remaining binomial after 9x squared has been factored out. We see that this binomial has been factored completely, since the only common factor remaining between these two terms is 1. To check the factoring, multiplication should yield the original polynomial. When directed to simply factor, it is understood that we should always factor completely. First step, determine the largest common factor. All monomials include the greatest common factor of 3. The largest common factor of the variable is x to the third, which is the smallest power of x in the original polynomial. Thus, the largest common factor is 3x cubed. Factoring each term with regards to the largest common factor results in the following shown. Then, using the distributive law, we can factor this trinomial into an equivalent expression of the product of the largest common factor, 3x cubed, times the remaining trinomial after 3x cubed has been factored or divided out. Since this trinomial has no common factor other than 1 between the three terms, we're done, except for a check by multiplication to determine if we do in fact have an equivalent expression. Looking at this example, first step is to determine the largest common factor. We generally factor out a negative coefficient if the first term is negative. In this case, that will be -3 for the largest common factor of the coefficients. The greatest common factor of the variables is x. Factoring the largest common factor is indicated here, and completing the step with the distributive, we see that we have our greatest common factor times the remaining terms after the factorization. And if you notice, the signs are the opposite of what they were because of dividing or factoring out the -3x. Note the 1 here in the last constant term in this trinomial, since the last term had only the common factor of -3x. This 1 plays an important role. Without the 1, the term -3x would not appear in the check. -3x times y is -3xy. -3x times -2z is a positive 6xz. -3x times 1 generates that third term that we started out with, and why it's so critical that it be here.